Good afternoon to all. We are back again with the day 2, session 2. Right now we have along with us Dr. Manak Lal Jain sir. Sir has visiting scholar position from the University of the Illinois at Urbana-Champaign, USA. He is a PhD from the Indian Institute of Technology, Kanpur, India, MTech from the Indian Institute of Technology, Madras, and BE in the engineering from Sri GES Institute of Technology and Science, Indore. Sir, having a research interest in the CAD, reverse engineering, modeling, simulation, biomechanics, and biomodeling. He has published a total 40 research papers and presented his research at the different international and national platforms. Paris, Urbana-Champaign, USA is the one among them. Dr. Jain, having more than 28 years of teaching and research experience, presently he is a professor and the head at the Department of Mechanical Engineering, Sri GS Institute of Technology, Science and Indore, Madhya Pradesh. So we have very privileged to have here Dr. M.N. Jain sir. Sir, on the behalf of Technical Events at Faro University, we welcome you, sir.
Thank you very much for nice introductions. I am happy to participate in these particular events, and I requested Parul to somewhat focus on the research areas that what is going on across the globe, specifically in rehabilitations engineering area sites. So I got these opportunities and feel happy that I am somehow able to communicate you remotely and express my observations, my understandings, and some of the applications of technologies in a specific domain, which is very much needed since long in the medical domain. And we as an engineer, somehow helping those medical peoples to diagnose the particular evil kinds of things, particular disease structures or particularly disease of interest by providing certain advanced technologies of engineering side. So under that presentation, I'll like to familiarize the audience with some peculiar kinds of product development technologies, and then how these technologies are useful for rehabilitation engineering. That's my total objectives of this today's talk. I'll skip some of the slides which are not needed for the audience, and which is very difficult to explain all those in limited time duration of time. So this is what I am going to begin, and now without wasting much time, I am coming to the points. I'll try to finish my presentation, and I'll give my all liberties to the audience to ask me anything, or in between also they can ask if something is difficult for you people to understand, right? So the organization of presentation is in India, as you know, a lot of startups are going on, and every peoples are looking how the entrepreneurship is possible, how successful a business model can be prepared, and our objective and our motto also to teach the students in such a way so that in case if they did not get or do not get any job in present market position, then they are having sufficient abilities to develop themselves as an entrepreneur and impart other servicemen peoples in your organizations. So that is something I kept in presentation. Then nowadays the internet things, IoT, you might be knowing, and with that IoT, how the products are developed, or how the digitization of product development is possible, which is a very fast developing technology. So overall objective is to give the digital manufacturing clues to the audience, and this particular cloud, how it is useful for certain case studies, and then finally summary. Lot of things is there, provided I'll get the time, but I have limited time, so I'll skip some slides. Now, what is digitizations? Digitization is one, basically control everything in pixels, electronics units, right? So this changes everything in the current scenario, right? The next $1 trillion will be earned with data for our customers and for our industry. That is what you are observing today. Nowadays, WhatsApp is fighting for his own data, and then your Facebook is another ways, and a lot of Chinese companies are there. They are collecting the data, basically human behaviors, human activities, and a lot of things, human liking, all those kind of things will be there. And then they are having a R&D sections in their companies or their IT sectors, where they are understanding how the scenarios, thought, thinking of the people's present young generation, present child generation, after 30 years, after 40 years, after 20 years, right? They get some ideas from those lot of data scattering kind of things, and then they are developing, they are planning their manufacturing unit, their production unit to go in their directions after 20 years, so that they will capture immediately. Every task, every business nowadays in present scenario is hardly a 4 or 5 year job. The product is rapidly changing, and you can't earn, you cannot get anything after 5 years if you will not update your products, right? So the companies are moving in a race in that direction, that who are capturing maximum data and who are preparing a model for next generation in least minimum time. Nobody was expected 30 years before, 40 years before, when there was conventional STD booth was there, and conventional phones in domestic life. If you have experience, two one mic and other kind of headphone telephones was there. But nowadays conventional telephone, no one are using BSNL landline kind of things for fast moving. A lot of people's having mobile phone. Then in mobile phone now, a lot of applications are there that are so useful for the business kinds of things. So everything is data. They, this whatever the applications are coming in scenario, they are already tried for developing those kinds of applications 20 year before, 10 year before. That's why we are enjoying this thing nowadays. Anyway, so this is overall the digitization important. This is the models that how the digitization change. So from bookstore to e-store, e-books, a lot of textbook, uh, also they are coming in digital form, and digital copies are there. Then from yellow pages to, from taxi, or from yellow pages to ride sharing, your Ola apps are there, a lot of similar other apps are there. So this is the scenario of the digitization. Then what are the applications of the digital technique, and specifically uh, the technologies of existing engineering technologies for product development, how these are useful for market trend changing and for entire society changing. So this is some limited application that I understand the audience are listening me and are clearly visible my presentation. Am I right?
Yes, sir. Yes, sir.
Fine. Okay. So the copy part, no original design is needed. In earlier time, the map of a colony, map of a home, or map of a factories, no one are giving for their security and secret point of views. Nowadays, market manufacturing product development companies don't need original design. They simply need the product. If they have a one single copy of product, they are having the expertization technique with them, that they copy it, they immediately digitize it. So copy a part here, no original design is needed. Existing part, its analysis and modification is possible in a limited time duration. Aesthetic design, wooden or clay model is first conceptualization. First conceptualize matlab basic units of product development is sand model or clay model in this fast product development scenario. Then custom fit for human surfaces, helmet, shoes, space suits or prosthesis. This whatever the engineering I'm going to explain you, This is another application. Then in manufacturing sector, then in inspection and quality control, and in art and sculpting sections. This is the applications of the technology. Now, copy of part is needed, no original part is needed in reverse engineering. This is the definition of reverse engineering. Till now, most of us know the conventional engineering process, which is forward engineering. The engineering till now we are studying in engineering institutes is forward engineering. Nowadays, the concept of reverse engineering is coming, that how you are moving from product to new product or from product to existing product. So this is known as reverse engineering. So if you see, I have just briefly explained it in this diagram. So if you are having a part, you you do its reverse engineering, and then you got again this computer part through computer aided design. So you need a original parts, then you digitize it by 3D scanning. I'll going to explain you 3D scanning. Then you process these data in product development software, mostly in engineering industries, specifically where replica is to be developed. So there are a lot of CAD software are there. So you process all those data, 3D scan data in CAD solid modeling software, which may be a KTR, which may be a unigraphic software, and then you do 3D product, 3D computer models, solid models, and then you prototype it, you'll get the original. So this is briefly what do you mean by reverse engineering. RE, mostly we in brief we are summarizing it. So data, how the acquisition of data are done, because in previous reverse engineering side I said original, then you do digitize it. This is the part, digitizations is the data acquisitions basically. And then once you acquire the data, once you are converted into the digital copies, then this digital copy is to be prototype, right? So I am just briefing over here. A lot of technologies are there for data acquisitions. These are briefly some of the major which is most commonly used, and you already have its seen in your eye. You have visited so many technologies, but previous to this presentation, you was not able that for what purpose it is used. So there are two basic kinds of technologies which is used in data digitization kind of things, or you can say for acquisitions of data in reverse engineering area. So one is non-contact methods and another one is tactile methods, that is a contact methods, right? So contact method is a old conventional technologies, but the recently developed technologies, and which is nowadays very rapidly coming into the markets, and lot of engineering college are acquiring it and keeping it in their laboratories, is non-contact methods. You need not to contact any items and you digitize it, right? Earlier there was a tactile methods, again two kind of thing, robotics arms and CMM, coordinate measuring machine. So any product, if you keep it, you have to touch with some robotics arms. Its features you have to touch. For example, in case if you want to develop a face, so you have to digitize the entire face. So if a face having a 10,000 points, so you have to touch the 10,000 points, and then you enter into the computers those points. Then this will store as a XYZ coordinate, and that is nothing but it the a robotic arm is there, and in arm the probe is there, and that probe you have to put at particular specific locations. Once you put it, then you enter the enter key of the computers, and then you will get that particular point. So you are understanding that how consuming time those technologies are there. So nowadays looking to the much time consumptions, mostly they are moving toward the non-contact kinds of method. So this is again three kinds of things: optical, acoustic, and magnetic. Opticals are there where we are using mostly your UV light or your um, laser light only for acquiring the XYZ coordinate. All these non-contact methods are coordinate measuring systems, coordinate measuring machines, but they are not touching to the object. But concept is same, but here no mechanical arms is there, but only optical cameras are there. Then acoustic, mostly the basic principle of acoustic is you might be knowing ultrasonography. So they are vibrating a mechanical crystals, and that crystal vibrate, and the vibrating signals are captured into the systems, and then based on the intensity, based on the densities of vibrations, they are developing the pictures mean digitization of existing 3D products. Then you are having magnetic uh, kinds of things. So magnetic kind of thing is again in medical domain. If you listen about MRI scan, right? So this is magnetic resonance imaging, MRI, right? Working on magnetic principles, and it digitize the inner parts of the human bodies, right? And giving some uh, density differences of tissues, and based on those density differences the images are captures, right? We in reverse engineering mostly are using optical sensor, and broadly we are saying it optical scanners, right? So there are different kinds of optical scanners are coming into the market. Mostly the industries are using ATOS scanners and optical scanners. This is an optical scanner. Again, the optical scanner are of two types. One is handheld and one is ground held, right? You are visiting this ground held, I mean, for stability point of view, for concentration point of views, it is fixed on tripod, and we fix the location of the object to be captured, and this is how it is digitized. uh, Basically the scanner principle of working is similar to human eye, where images are formed. So we are having two eye on our left side and right side. This eye focusing on certain points, and that particular points image is generated in our retina. That is a third, you can say, processor, right? That's a third item in a brain, that is known as processor. It process all those points and generate an image, and that is how it is sent to the brain, and that is how we are realizing. Same observation concept is utilized in optical scanner, right? So it uses two eye, two laser emitter source, and there is sensor in between them. It senses the focus point of two inclined laser, and then it will send to the central part, that is brain part, to the human brain, and that is how it acquiring so many points, it's so many features, it's so many location of a given product, and all those points with certain algorithms, it's generate the image in the computers, right? So present you are having a left hand side product in a physical component form. A god is there. This god, with the help of present central technologies, scanning technologies, it is digitized, and how the digital copy is looking, it is observed on the extreme right side, right? So the one is physical, and then we are having it's a digital. Same faces, same features, same organs, same shape geometries is there. This is how the technologies. That was a small god sculpture, and this is how a big aerofoil is there, right? So you can scan as big as possible, or you can go for as small as possible. This is possible in this scanning modalities, and where different specification is there for different range of items. So here we are scanning it, the aerofoil of a helicopter, right? Tactile methods, as I said, robotics arm is sensing device in joint of arm determine coordinate, but now it is robust and slowest method for data acquisition. So mostly now it is not used, right? This is the what the robotic arm was working. You are having left hand side, देखिए यहाँ पे there is a robot is there, and then its arm is there, and then at the extreme end point of the arms you have a chuck where you fix different kinds of probe, and then those probes are to be touched here in this shoes, original shoes, and then you are having a digital shoes with you, right? This is how modeling surface to surface modeling, then solid modeling, unigraphics in KTR, ProER, so many Creo kinds of thing is there. That is how shoe is digital. You are having first initial physical parts of shoes, then you are having curve model, then you are having surface models in CAD, right? So another technologies which is used is rapid prototyping technologies. Nowadays, I think most of the engineer, I mean, majority of the engineers are knowing basically what is prototyping and what is 3D printer, right? So this is a 3D printer. Most of you know, so no need to explain in much. Now we have studied two technologies. One is for digitizations, and then one is for prototyping. Now I'm giving this for how these two technologies are useful for rehabilitation engineering. So I'm interested to omit some of the slides over here, or I skip the slides, and then we are uh, having other interesting uh, mod of presentation, which is the title of today's presentations, right? So in preparation of the saddles, which is a horse back seat for different riders, for different countries, for different continentals. The shape geometries of the back of the human bodies is different. So how best fitted these two parts are there, how we develop a seat, which is known as basically the saddle, is in interesting areas of reverse engineering, where India is preparing so many saddles since last 10 years. It earning a lot of foreign currencies with this CAD came reverse engineering technologies, right? I think three or four big industries are there, saddle industries in India. They are directly getting the contact from Europe, from Americas and other Western countries for this saddles designing and product, right? So here we are applying reverse engineering. You are having a digital copy, then these digital copies is to be models, and then how these shape geometries are converted into a prototype kind of thing. There are again another feature based reverse engineering is there, where we are interested in features kind of things, and then all those features are to be summarized, or all those features are boolean operation are performed on all those features, and then finally we are getting a mathematical models, and then this mathematical model is to be converted into a solid model. So this is another approach of modeling kind of things. This is in saddle tree of 17-inch, how this is developed. So again, digital model and its analysis are there in finite element analysis, how the errors are there, which is what is desired and what is developed. That's error analysis is possible. This is again a cycle for multiple part product development. On left, right, on left top, we are having a digital copies. Then on top right, we are having its features, different features, defined features, uh, surface solid models, and then you are having its prototype, that is RP models, rapid prototype parts, and then this rapid prototype model is used for generating the die for multiple 10,000 pieces or 20,000 pieces in injection molding machines. So how the dies are developed, this is again uh, interesting parts in technologies, and lot of products are possible with same die. Again, now coming to the rehabilitation engineering areas, so we are having a x-rays technologies, and the same x-rays technologies are involved in basically uh, x-rays imaging technologies, that is CT, computerized tomography. X-ray imaging technologies, we are getting only a single slice of an X-ray, and based on certain crucial critical cross sections, we are taking the X-rays, and the limited slices we are studying, and based on those limited slides observation, and based on single slide observation, the radiological give its radiological reports, and that radiological report is studied by another doctors, and then he prescribe his uh, medications to the patients. That's a similar concept is employed in computerized tomography, where we are having different tomographical observation, tomograph, different slices at different thickness of an entire beam. For example, if one is interested to develop a uh, ulna bone of the human hand or tibia of a human bone of a human foot, then in that particular conditions, you put the entire foot lower extremities into the CT scan machines tables, and then this table is able to move the subject in forward and backward directions. And if you want a slice of less than 5 millimeter, you arrange the speed of the table uh, such that we are having 5 millimeter slice we are getting. If we want a further thin slices, then you again control the speed of the tables, spring of the, yeah, spring of the table that is moving inside the CT sources, which is in generally a ring kind of shape is there. So you simply adjust the table speed and you are getting the slice thickness. So this is how a 3D models of the human foot is developed. We are having one CT slices, similar kinds of slices are as many 20, 30, like bread, eating bread, right? Bakery bread. If you see so many slices together and you put one over other, one over other, one over other, you are having a 3D parts, very good looking, right? Same concept is apply over here. You put slice over slice, slice over slice, slice over slice in CAD software and develop a 3D solid models file, and then this 3D solid model file is to be converted into a manufacturing file. A manufacturing file, you apply the technologies and convert that manufacturing parts into a 3D physical parts. So conversion of CAD file to manufacturing file, the conventional or the old concept name of that particular file is known as stereolithography, right? STL, stereolithography. So you convert that CAD uh, models, solid models into a stereolithography file, which is a manufacturing file, and put this manufacturing file into a 3D printer. All those, all globe 3D printer are welcoming only stereolithography file. They are not welcoming any other format of the file, because all vendors of the CAD software, they agree to a single point that they are having their model file in their proprietary names, but each proprietary name are having capabilities to develop a single file which is acceptable to the globe, right? So they have developed a common format which is known as stereolithography file format, and all software, whether KTI is there, whether Unigraphic is there, whether Creo is there, they all successfully develop a STL file. So you prepare the manufacturing file and send it to the 3D printer and instruct him that you go on developing a 3D print form of this particular file. That is what I am giving you in digital form, and it is a STL file. So printer understand, yes, I'll do it, and then he'll start working as soon as you are giving the command, or you are giving a menu operated command that yes, hold, so it will start functioning. So this is what involved in human foot anatomical areas. We are having a CT scan of the human foot, and then how this human foot are to be prototype. That is overall objective of this particular slice. Now moving to the other interesting case studies of this reverse engineering is to how to develop some orthotic devices for rehabilitation of um, human abnormalities, and we are very much interested for human babies abnormalities. So most commonly there is a abnormality, or there are abnormalities in the human foot, that some baby born with flat foot. I think you uh, some of you are understanding that how the flat foot babies walk. He or she facing some problems in running kinds of walking process, or in even fast walking process. Those people are observing some problems, right? But those who are having an arc, those people are not facing running problems or other problems, because the arc is acting as a bridge, and this bridge has a capabilities to bear the shock which are developed during the running kinds of thing. But flat road is not able to absorb the shock, not having much capabilities to absorb the shock, and it may develop cracks. So that kinds of engineering phenomena may happen in foot, and the subject facing the problem. I'm moving toward a deformity correction, which is most commonly known as club foot, right? What is club foot? This is the structural deformities of the foot that occur at birth or during childhood. It has abnormal posturing of the foot, which causes him or her to turn the ankle inward and walk along the outside edges of the foot throughout the life if it is not improved at most appropriate corrected time. You know, everything is having time for successful presentation, or for successful product development, or for successful period in the life to get some opportunities. So that's if one is giving correct dose at correct time of the sickness, more chances are there to treat the people in a better ways. So this is what uh, abnormality is corrected if it is diagnosed at right time, and treatment is started immediately when it is diagnosed. This particular deformities of the foot, club foot, it is a generalized terminology, is very widely used by many societies across the globe. Another medical terminologies of this abnormality is congenital telepath equinovirus, CTEV. Briefly, they are summarizing that. Check that particular baby is having CTEV deformities or not. Go and check senior doctors giving instruction to the younger pediatrics doctors, or even to the gynecologist, that how they are briefing these abnormalities in medical literatures is CTEV. So this is basically two types. It's a type, two types are there. If it is existing in both the foot, we say it bilateral uh, deformities or bilateral CTEV or bilateral club foots. If it is happen to possesses in one foot only, then it is summarized as unilateral CTEV or unilateral club foot. How it look like? So this is the structure which is we are observing to the foot. If one foot is bent inward, right, then we say it has the subject having a clubfoot deformities. If both the foots are bending inward, then we define it to be a bilateral clubfoot deformities. In any deformities, the subject has a tendency to walk along the outside edges, right? So that's walking behavioral studies. Also, you can say that's a clubfoot deformities, or even by shape geometry observation, you can say the baby has a uh, foot deformity. We are applying our recent technologies or advanced technologies for development of a device which is known as orthosis and applied to ankle. That's why it is known as ankle foot orthosis, briefly AFO. Right? There are two kinds of prosthetic. There are two kinds of foot correction devices. One is prosthesis and other is orthosis. Prosthesis is a terminology which is very widely used in medical side. Uh, it is basically a device which is an aid to a subject for performing its routine activities, routine life activities, for routine work of the human bodies comfortably throughout the life. Right? That is known as prosthesis. I mean, the part which is useful in place of original missing parts and perform the routine work of the human bodies throughout the life. That is a subject uh, missing his organs, and another substitute organs are fit into it, and he is instructed to do a particular kinds of work. That is known as prosthesis. On the other side, orthosis is another a temporary fastening device to the subject, and once the uh, temporary looking behavior or temporary shape geometry is converted into a correct shape geometry, then that particular fixture is removed. So those parts which are removed and fit temporarily, these are known as orthosis devices in medical arena, right? For example, belt, LS belt. You might be understanding some people facing ache in their back while walking, while sleeping in the night. So they are doctor prescribed them a LS belt, lumbo circle belt. That's orthosis. You wear it for limited time duration, and once you are okay, when you will become okay, when it's orthotic joints position, muscles, nervous system, which was went in different shapes due to some jerking kinds of activities. So it goes into different shape, but by wearing the belt slowly and slowly within month or duration time, it come to back into the original position, and then the subject feel comfortable. Once he feels comfortable, the device is removed. uh, so those kinds of device are even some of the people facing problems in their neck, right? These kinds of joint they are having facing problem, so doctor prescribe them a collar, right? Wear it for 1 month duration, wear it for 2 weeks, wear it for 3 weeks. Then after wearing such a small duration, he'll feel okay. So he instruct now remove the collar. So that collars, LS belt, and similarly many kinds of things. They are known as orthosis. So orthosis is a device which is supporting to the human body interface for some limited duration of time, and then it is removed once the subject is okay. So this is known as orthosis, and when this is applied to the foot, it is known as ankle foot orthosis. So we are developing a unique medical device for this correction of club foot, which has sufficient capabilities for functionalities, then from strength point of views, and then from ergonomics points of views, and then aesthetics, that is looking point of view. I mean, looking point of view, ergonomics point of view, it should have sufficient strength, it should have a pleasant kind of functionalities, right? So all those characteristics are needed in a product, then only it will come into the market. So before development, the we are interested to see the biomechanics behaviors of the human abnormal foot, how it is bring into a positions which is said to be a medical correct position. So these are different physiotherapical ways of correcting the club foot, and this technique which is successful since last 5 years by manual doing kind of thing. This is the overall objective of the present existing technologies is how to utilize all those technologies to solve these 500 old problems, from mechanical to automatically, right? Everything now it is digitizing, everything is making automatic. So we are moving in that directions, and this is how a clue is there which we are using in our digital areas. So methodologies, we first have a abnormal food data, then we use the image processing tools to organize all those scan data to develop a solid models. Once we are having a solid models, then we are using its manufacturing files. Once we are having a manufacturing files, then we use it for the prototype development. Once we have the prototype of club foods, then we had developed its a rubber club foot models. I mean, we don't need rigid plastics models, but we need simple, uh, soft soft movement where we can apply the physiotherapy, and we see how the rubber foot are behaving. So silicon models help in that direction. Then this once we develop these silicon models, then we develop this with orthopedicians, and then we are doing some in virtual analysis based on orthopedic guideline, and based on our digital data. We use some finite element uh, methods, simulations tools to simulate them with respect to the correct or right physical pointed directional converting load for normal food behaviors. We are applying all those load in different magnitude, and then we see how food is changing its shape. So virtual simulation technology we have utilized. Then we develop experimental stress analysis also. We apply the physical load by putting different strain gauges at different physical locations, instructed by medical peoples like senior orthopedic surgeons, that this is a pressure points where you apply the load, then you are having a correct deformation in correct direction. So keeping their prescribed positions, we apply the load in virtual simulation software, and we see how the foot is working. So that's perfectly right methodologies, and based on this data, simulation data, we are designing the ankle foot orthosis mechanisms to operate it automatically instead of manual corrections. And then this device is developed, discuss with modifications from doctor's point of view, and then from audience or patient point of view. We apply these tools, patient react, patient parents are reacting. Based on there, we again modify it, and then we develop a final acceptable ankle foot orthosis into the market. Right? That's overall objectives, and how up to what extent we are successful is the objective of forthcoming slides. So this is a soft 3D models of the club foot, which is obtained from MRI scan of the baby's correct live patients. So figure first one is the bilateral foot deformities of a 6-day-old male baby, right? Top right is the unilateral clubfoot deformities of a 1-month-old babies. Then bottom left side is the soft, or you can say light, unilateral clubfoot deformities in a 40-day-old babies. Then extreme right, extreme bottom is unilateral deformities of again 1.5-month babies. Overall scenario is to develop prototype, because engineering peoples are doing with engineering product in its laboratory. They cannot have the live human subject in engineering labs. Medical peoples having the live subject. So overall objective is engineering discussions among the shape geometries, and we have developed prototype for this one. This prototype is to be converted into a rubber models. You can see this is a rubber silicon models, and these models some suitable strain gauges or some sensors are fixed as specific anatomical location as suggested by orthopedic peoples. Some sensors are fixed, and these are connected to the sensor uh, एनालॉग टू डिजिटल कन्वर्शंस, राइट? ए टू डी कन्वर्टर के थ्रू में जो है इसको डिजिटाइज करते हैं, एंड देन इट विल सेंड टू द सिस्टम फॉर simulation purpose. So based on those simulations, we propose some mechanisms, and this is a 8-bar chain mechanisms which we have planned in futuristic ankle foot orthosis. So firstly, it is designed mechanically. So you are observing we are having some pinpoints, I mean some kinds of joints we have utilized for this orthosis, which is ball and socket joints, and then pin joint, and then some fixed joint, right? So these joints are assumed, and this mechanisms is diagram in central part of uh, photograph. And then on the extreme right, if we move one arms, how it is the entire foot kind of things are moving through different uh, angular positions with respect to different kinds of joints. So that's a path, shape geometry, or motion analysis. Center one is picture models, and left side is mechanisms involvement. Now we are having the baby's image with us in a models. The overall objective is to develop a mechanical fitted components in these digital copies of the foot, right? So the best fit is that if we get a shape geometry which is similar to the foot in a product, then the product and the foot will be best fitted. So we have taken a digital point cloud data of the subject that already we are having a in CT images or MRI images, and all those images are given a command to develop the points, so they scatter their point based on their images, right? Then these points are segmented. I mean to say that some of the part is removed and some of the part is kept for our interest. So this is how one foot is taken, and then half of the entire uh, length of the foot is cut down, taken out, and then this is the parts which is left, and this left part is used for development of this curve model and surface model in a CAD software, and then this CAD software surface models are developed from these curve models, and then these curve models simply are offsetted with certain distances which is to be required for the development of the product. You need a 3 mm thickness of the product, so we offset the surface models with 3 units. If you want 5 units, 5 mm thickness, then you simply offset the surface model with 5 units. So this is offsetting model of offsetting ways of surface model. Then these offset models are break down into 3 components. One is shank part, one is mid part, and one is back foot parts. So uh, back foot part we normally say hide foot. So upper foot, that is upper part, then hide foot, and then front foot. These are 3 different segments. We get these 3 different segments over here. I mean, basically, we develop this entire component in 2 parts, and then a third part is to be accommodated in first and 2 parts, and which is the basic joints, ball and socket joints of this particular orthosis. So we model accordingly, design accordingly in CAD software. We utilize the synthetic means synthetic look also, ergonomic look also. uh, we design some features and these are incorporated, and then these 2 right pictures is manufacturing file of upper part of the orthosis and bottom part or 4-foot parts of the orthosis or of the AFO manufacturing part. These manufacturing parts are fired, are given to a 3D printers and ask them to give us the physical components. So they gave us 2 components, and these 2 components are joined together with other 8-bar chain mechanisms, limbs or arms are elements of 8-bar chain mechanisms, of which these 2 prototypes are links, right? So 2 links, with basic 2 links we design in CAD software, and out of the 8-bar chain mechanism, 2 links are getting from the point cloud data, and rest of the links are designed by ourselves based on the crucial ball and socket joints center point, right? So this is the extreme right. You can see it's a uh, complete orthosis, and which is to be kept fitted to the babies. Before fitting to the babies, we are checking it on our own silicon foot, and we are applying some anatomical shape geometry changes loads to the mechanical members, that is fly nut. We are giving some rotations, they give the motion in theta angular positions of the foot. So with 1 degree changes, with 2 degree changes, with 3 degree changes, how the baby is feeling when he start crying, right? All those doctors observations, and we gave them device to quantitatively shape change of the deformed foot, which is not possible since last 500 years, right? So this is a unilateral baby patient, and initially he was cast with a casting plaster of Paris, and this unilateral foot we are using it, and then we are applying the developed orthosis in our laboratories. The data of this patient was captured, and then we obtained these geometries and we fitted it, and we are testing in our clinic, right? So overall, these are the, I mean, this is overall the technologies which is useful for development of orthosis. A lot of clinical testing is going on. We are changing many shapes. We are satisfying many uh, patients, but still we are not getting a perfect shape of the orthosis, because lot of baby is having lot of custom changes. So we are, overall the objective is to get a successful 100% rate, then we'll come into the market. So the trial and error are going on. We are having some doctors with us, and we are having some modeling design team with us, and I mean the entire studios, design studios is working on hard on this and device, and soon we are going to break the market in that area. I think the time is limited, and I have to stop over here because a lot of things are there for other parts of the presentation, but that we'll discuss in some other parts of the programs in coming futures also. So I'll think I'll stop at this particular location, and I welcome audience to get their questions. Okay, so I'm exiting.
Yeah, it's really very nice and wonderful session, sir. Definitely, I believe that all the student and all the viewers can be take the lot of the knowledge and advantage from your lecture. So right now we have two professor with us. We have
Okay,
Professor Sumit Lala Das. Sir is a doctor, and he has some queries about the these innovations and rehabilitations. So I would like to request Dr. Sumit Das Lala, sir.
please.
Very good afternoon, sir. It was
Thank
indeed a
you.
nice presentation. Sorry,
Good
I
afternoon,
joined a
sir.
bit late because I was having class. But it was
Okay.
indeed a very nice presentation. So one thing I need to ask about that is that the options is the material that we are using. What material actually you are using for developing this?
Very nice. We are only able to test the babies or test the medicos people with biocompatible materials, right?
Okay.
So we are getting different grades in ABS, acrylobutadiene styrene. We are having
Okay, okay, fine.
different commercial grades are there. One grade is
Okay.
biocompatible ABS, so we are using
Hmm.
that polymeric materials.
That polymeric material. Okay, sir.
Yeah.
Sir, one more query I actually have. What is the basic difference between this and scaffolding? Because I have some of my work in scaffolding done. So, what is actually the basic difference between these two? I'm not clear about the concept.
Hey, what these two I'm missing in between your audios basically. So you just say me what is two.
Oh, okay, sir. The orthosis process that you are using for your babies, and if we are go for using scaffolding process for that, what is the basic difference between them?
Very nice, good. Very nice. Those kinds of device basically they are rigid devices, right? And
Okay.
all those rigid devices are available in different grades only. I mean, A size, B size, and C size. I mean, standard sizes are there only, right?
Okay.
On the other hand, this other device is having a dynamic devices. I mean to say that you are having capabilities to impart the loading position in a dynamic ways, and there are no standard size, but there are fixed custom size. So success rate is more in this second kind of things as compared to old one.
Okay, fine, fine, fine. Okay, so that would be fine from my side. Thank you, sir. Thank you very much.
Thank you very much. Good questions.
Thank you, Dr. Sumit Gala. Now, sir, we have the Professor Ajhar Patel, sir, with us. Professor Ajhar.
Good afternoon, sir.
Good afternoon. Very good afternoon. Akshay, please.
So first of all, this is sir, it was very nice presentation, sir. I just want to ask one question: that how mechanical students can see the opportunity in this field? I mean, how they can contribute in this field,
Very
or we
nice
can say what
question.
are the research opportunities that mechanical engineering student can see in that?
Very nice. I mean, it's a very good questions. You know, nowadays the scenario of the world is changing. Earlier, computer science people are knowing only their computers algorithms, and they kept busy with them. Their scheme of studies is busy with only mathematicals and program development kind of things. Now they are having some pursue in different directions also, like how the product, how the physical component is digitized, come into the digital forms, and then how they are processing it. I mean to say that nowadays the platform is open for multi branches kind of things, multi engineering task, multi engineering discussions, kinds of things. So it is not necessary nowadays to work on simply in automobile areas or simply in machine part. That's a mechanical engineering. Now advancement of mechanical engineering is there, where we are having mechatronics subject, we are having some fms areas, and robotics kinds of thing are also. Mechanical discipline is evergreens, and it is expandable in every automatics area and in digital field also, right? So one area is medical device development with applications of simply mechanical concept. So biomechanics is there, then your reverse engineering is there, image processing is there. Nowadays prototype is there. So that's a big challenges and big beginning to the medicals doctor, that they are now getting the prototype of the organs which is inside. Previously they are only capable to observe them in a picture form, but now it is in their hand. So it's a revolutionary changes are there, and all those pictures, mechanical engineering basically prove a great roles, right? So one lot of areas, lot of branches are there, and they can accept all those branches, and they start growing in that direction also. Yeah.
Thank you so much,
Okay,
sir.
thank you, Ajhar Patel, sir. Now, sir, it's really a wonderful session. We have run right now the series of the lectures, where today our second day and the second session means two session is still left for the tomorrow. It's really wonderful with you, sir, as usual. Thank you very much for being with us, and thanks a lot from the technical event cell, Parul University, sir.
Thank you, Om Prakash, and I wish my best for the Parul universities and the audience. I think they enjoy in noon parts of the day. So thanks once
Yes, sir.
again for the platforms providers and for the audience also. Yeah. Bye bye.
Thank
See
you,
you.
sir. Bye, sir. Good day, sir.